Progress check 1, number for GCSE higher tier. Question number 1. Write this recurring decimal as an exact fraction in its lowest terms. We've got 0.7 recurring. So this is one way of writing that, meaning that 7 would repeat itself indefinitely. And this is another way of writing it with a dot on top of the digit that repeats itself. So the quick way to turn this into a fraction would be to write the digit that repeats itself, and that's the 7. And there is just one digit that repeats itself, so we're going to have just 1 9 at the bottom of the fraction as the denominator. So it's always a 9. So if we had 0.333, for example, or 0.3 recurring, we'd have 3 out of 9. If it's 0.4 recurring, we'd have 4 out of 9. So with the one-digit numbers, we would have a 9 at the bottom. But why does this happen? Let's have a look. So 7 divided by 9. How many 9s would fit into 7? There would be 0 of them. So 7 is carried over. Into 70, there would be 7 of them, which is 63. So take away 63, that leaves us with 7 again. So into 70, it's 7 lots of them. As you can see, the pattern repeats itself. And it would be the same thing if we divided maybe 5 by 9. So how many 9s into 5? That's 0 into 50. That would be 5, which is 45. So 5 remaining again. So it's the same pattern. You can try it out. So maybe 1 divided by 9, 2 by 9, and so on. The one-digit numbers, except for 9 divided by 9, which would give you 1. So why is this the case? So if you look at 9 times 1, that gives us 9. So it would be 1 remaining to get to 10. If you do 9 times 2, it would be 18. So it's 2 remaining to get to 20. 9 times 3, it'd be 27. So 3 remaining. 9 times 4 is 36. So 4 remaining to get to 40. You can see that pattern because when we do division, we add these zeros in there. So we're looking at how many would fit into tens. So lots of 10. And that's why this is 1 remaining to get to 10, 2 remaining to get to 20, 3 to get to 30, 4 to 40, and so on. So 9 is that special number which is so close to 10. So always if you have one digit repeating itself, it's going to be out of 9. I'll show the algebraic way as well to solve this. So if we let's say 0.7 recurring to be x, and we multiply this by 10, so we get then 7.77 recurring. So this was 10 lots of x. Taking away the bottom number from the top one means that we're left with just 7. And looking at the x's, we get 9x. So this one is the numerator and this is the denominator. So 7 9ths again. Now in the second question we've got 0.24 recurring. So we'll write that as 0.24. Now we've got 2 digits that repeat themselves, and so we're going to need 2 9s at the bottom. So 24 out of 99. If you try to divide, again, the same thing would happen as it happened above in the previous question. So getting 24 divided by 99. How many 99s into 24? That is 0 lots of them. And adding a 0 to 24, making 240. How many 99s that would be? That's just 2 of them. And we have 42 remaining. So adding a 0 again, that would be 4 lots of 99. And that leaves us with 24. So again, putting a 0, that's 2 lots. So you can see the pattern repeating itself because 99 is 1 less than 100. Just like 9 was 1 less than 10. And then division, we use base 10. So it's how many fit into 10, 100, or 1,000, and so on. Now looking at the algebraic way to do this, so if we let 0.2424 be an amount x, and we multiply this by 100, because we have 2 digits that repeat themselves rather than 1 above, as we had above. So 100x, so that makes it 24.2424. Taking away the bottom number from the top one means that these will cancel each other out, and we'd have only 24. And 100x take away x gives us 99x. So the fraction would be 24 out of 99. Now, can we simplify this any further? And I can see that 24 can be divided by 3, and so can 99. So we'll make this 8 out of 33. So we'll write here 8 out of 33, whereas here we couldn't simplify it any further, so it's 7 out of 3. In question number 3, we've got the same type of question, just a different decimal. So we can identify which of the digits repeat themselves, and that's 619. So 619, it's 3 digits, so we'll have 999 as the denominator. And the algebraic way is like we looked at before. So if 0.619619 is x, and we have this multiplied by 1,000 now because we've got 3 digits, so we're going to give it 3 zeros, so 1,000x, we go 619.619619, taken away, we're left with 619, and 1,000 take away x, 1,000x take away x, leaves us with 999x. So this is the numerator, and this is going to be the denominator, 619 out of 999. Now this cannot be simplified, so we're going to write it as it is. Looking at question number 4, we've got 4 digits repeating themselves, so we've got 7, 2, 3, and 5. So the short way to do it is 7235 out of 9999. So the number of digits matches. So to show the proof of this using algebra, we will go to represent 0.7235 with x, and we'll now multiply this by 10,000 because we've got 4 digits, 1, 2, 3, 4, so you must have 4 zeros, so 10,000x. So multiplying this by 10,000 means we move the decimal 4 places to the right, 7,235.7235. Taking away, this leaves us with just 7,235. 10,000 take away 1, that is 9,999x. So this being the numerator and this the denominator, we get then 7,235 divided by 9,999. Now looking at the numbers, we cannot simplify this, so we're going to write it as 7,235 out of 9,999. In question number 5, we've got work out the value of the following, leaving your answer in fraction form when necessary. We've got 49 to the power of half. Now, you probably know already that the rule for this is that 49 to the power of half is equal to square root of 49. So raising a number to the power of half means that we're square rooting the number. So this gives us 7. Looking into proof or way to remember if you've forgotten the rule, then I'm going to use an example. So if we have, for example, 3 times 3. So if it's just 3 has a power of 1, so that gives us 3 to the power of 2, which also equals 9, or 3 squared. So if we have 49 to the power of half and multiply that by itself, it's just going to give us 49 to the power of 1, because half and half equals to 1, which is 49 itself. So we basically have done the same thing as raising to the power of 2, because 49 to the power of half has been squared to give us 49. So what is that number which is multiplied by itself to give us 49? And that's exactly the opposite of squaring. So we call that the square root. So that means that 49, the square root of 49 times the square root of 49 will give us 49. That was just a bit of extra information or proof for it, hopefully to help you remember. But the answer is 7. In question number 6, we've got to work out the value of the following, leaving answer in fraction form when necessary. So we've got 32 to the power of 2/5. We can rewrite this as 32 to the power of 1/5 times 32 to the power of 1/5. So we've broken 2/5 down. So because we can add a fifth and another fifth to give us 2/5. So what we're going to do now, we're going to work out what is 32 to the power of 1/5. So 32, that is the fifth square of 32, multiplied by the fifth square of 32. So the fifth square of 32, how can we work it out? The fifth square means that we've got a number which is multiplied by itself 5 times to give us an answer of 32. And that number is 2. So fifth square of 32 is 2 times another fifth square of 32, which gives us a total of 4. And that is the answer. In question number 7, we've got to work out the value of the following, leaving your answer in fraction form when necessary. We've got 27 to the power of negative 1/3. I prefer to split the negative from the 1/3. So I'll do the 1/3 first and then apply the negative to the power. So I'll go and work out 27 to the power of 1/3 first, which gives the cube root of 27, and that is 3, because 3 times 3 times 3 gives us 27. Now I can work out 3 to the negative power. So that is -1. And that gives us 1/3. To help you remember, I will give you an example. So if you have 3, the lowest of indices, that is, so 3 times 3 times 3 is 3 to the power of 3, which is 27. 3 times 3 is 3 to the power of 2, which is 9. 3 in itself is 3 to the power of 1, which is 3. Now what you notice is we dividing by 3 as we go down. As the powers go down, we divide by 3. So again, we're going to divide by 3 here when we drop the power by 1. So 3 to the power of 0 is going to be 3 divided by 3, which is 1. So now 3 to the power of -1 will be 1 divided by 3, which is 1/3. So that's what we had here. And just to help you remember for any future questions, if you have 3 to the power of -2, that is going to be 1/3 divided by 3, which is 1 to the power of 9. Because 1/3 divided by 3, which is 3/1, is the same as 1/3 times 1/3 again, because we flip the second part. So that gives us 1/9. So as the answer for this, we'll need to put 1/3. In question number 8, we've got 5 square root 5 can be written in the form of 5 to the power of n. Calculate the value of n. So 5 square root 5 is the same as 5 times square root 5. So 5 can be written as 5 to the power of 1, whereas square root 5 can be written as 5 to the power of half, which means that we've got to add the powers. So 5 to the power of 1/1 plus 1/2. Now to add the fractions, we've got to turn them into fractions with common denominators. So we've got 2, so 2/2 plus 1/2, that gives us 3/2. So 5 to the power of 3/2. And calculate the value of n. So we just need to write the value of n. So 3/2. In question number 9, we've got 2 square root 8, which can be written in the form of 2 to the power of n. Calculate the value of n. Again, we're going to do a similar thing to what we did in question 8. We're going to write 2 as 2 to the power of 1 multiplied by square root of 8. Now, square root of 8 is the same as the square root of 2 to the power of 3 because 8 is equal to 2 to the power of 3. And square rooting a number means that we raise it to the power of half. So this is going to be written as 2 to the power of 3 all to the power of half, which is also the same as 2 to the power of 3 over 2, because we multiply the powers, 3 lots of 1 over 2, or 3 lots of halves, 3 halves. So now I can plug this in here, so we get 2 to the power of 3 halves, and this means we've got to add these powers, which is 2, so 2 to the power of 2 over 2 plus 3 over 2, and then together gives 2 to the power of 5 over 2, or 5 halves. So n is equal to 5 over 2. In question number 10, we've got a is equal to 2 to the power of x, and b is equal to 2 to the power of y. Express 2 to the power of x plus y in terms of a and b. So this links to the rules of indices. Which rule is that? That tells us we need to add the powers. That is the multiplication one. So that means in order for us to have an answer of 2 to the power of x plus y, we need to be multiplying 2 to the power of x by 2 to the power of y. So if 2 to the power of x is written as a, and 2 to the power of y is written as b, their multiplication, so when we multiply them together, should give us 2 to the power of x plus y. So since we having to manipulate letters rather than numbers, we don't need to write the multiplication sign, the operation in there. So we're going to write just a, b, which means a times b. In question 11, we've got Terry measured the length and the width of a rectangle. He measured the length to be 745 millimeters, correct to the nearest 5 millimeters. He measured the width to be 600 millimeters, correct to the nearest 5 millimeters. Calculate the lower bound for the area of this rectangle. Give the answer correct to 3 significant figures. So this is a bounds question, and to make this a bit more clear, I'm going to start by writing the lower bounds and the upper bounds of the two numbers, the length and the width. So the lower bound of 745, which has been rounded to the nearest 5, is going to be 742.5. So I split that 5 in half. So 2.5 taken away would give us the lower bound, and added to the 745 would give us the upper bound. So the upper bound will be 747.5. We'll do the same with the other one. So upper bound will be 302.5, so adding 2.5, and now taking away 2.5 from it will give us the lower bound. So lower bound for 300 to the nearest 5 will be 297.5. Now, since the question is about the lower bound, we're going to pick the lower bounds of the two numbers, because multiplying the lower bounds will give us the lower bound of the area. So we're going to go 742.5 times 297.5, which equals 220,893.75. So 220,893.75. We're going to have to round the answer to 3 significant figures. So the figures or the digits with the highest value are the 2, 2 and 0 there. So we're going to have to stop here. The 8 determines what happens to the 0. Does it stay as a 0 or does it become a 1? And it is higher than 5, so we're going to make this a 1. So 2, 2, 1. And do not forget to make the rest of these zeros. So the answer is not 221, it's 221,000. So we'll write that here, 221,000. The unit is millimeters squared, but since these will be input into the system electronically, you don't need to include the unit. Question number 12 links to question number 11. So we've got Terry measured the length of the width of a rectangle. He measured the length to be 745 millimeters, correct to the nearest 5 millimeters. So the same figures we've got. He measured the width to be 300 millimeters, correct to the nearest 5 millimeters again. Calculate the upper bound for the perimeter, not the area this time around. So give your answer correct to 2 significant figures in millimeters. So first of all, we're looking at the upper bound, so we must work with the upper bounds of these numbers. So the upper bound for 745 was 747.5, and the upper bound for 300 was 302.5. And as we know, to work out the perimeter, we're going to have 2 lots of the length and 2 lots of the width added together. So we'll go 302.5 plus 302.5 plus 747.5 plus 747.5, which gives us exactly 2,100. We need to write the answer correct to 2 significant figures. So the 2 digits with the highest value are the 2 and the 1. So we look at the 0. 0 tells us that we shouldn't change the 1, so we'll keep it as it is. 2,100 millimeters, that is the answer. In question number 13, we've got to simplify the square root of 200. So square root of 200 is the same as the square root of 2 times 100, which we can also separate. So we can say square root of 2 times square root of 100, and 2 is not a perfect square, so we're going to leave it as it is, or we can simplify square root of 100, which is 10. So we can write this as 10 square root of 2. In question number 14, we've got to simplify square root of 8 times square root of 32. So we can rewrite square root of 8 as square root of 2 times 4, and square root of 32 as 2 times 16. Trying to get the perfect squares, the square numbers such as 4 and 16. So we'll rewrite this as square root of 2 times square root of 4 times square root of 2 times square root of 16. Simplifying, square root of 4 is equal to 2 and square root of 16 is equal to 4. And then we have square root of 2 times square root of 2. Square root of 2 times square root of 2 gives us 2. So we can write this as 2 times 4 times 2. 2 times 2 is 4, times 4 is 16. Or 2 times 4 is 8, times 2 is 16. So the final answer is 16. In question number 15, we've got expand and simplify where possible. We've got 1 plus square root of 2 times 1 minus square root of 2. So we'll expand the brackets by multiplying 1 by 1 and then by negative square root 2, and then multiply square root 2 by 1 and by negative square root 2. So we'll do first 1 times 1, which is 1. 1 times negative square root 2, which is negative square root 2. And then we're going to go square root 2 times 1, so plus square root 2. And then square root 2 times negative square root 2. So that is taking away 2, because square root 2 times square root 2 is 2. Having that negative in front, then we can say negative 2. So simplifying this further, we get negative square root 2 and positive square root 2. They cancel each other out. And then we have 1 take away 2, which is minus 1. So the final answer is minus 1.